Welcome to Maths with EJD. In this video, we'll be looking at data collection and sampling. Since we already know that statistics is all about collecting, analyzing, interpreting, and making sense of data so we can make well-informed decisions. So let's look at how we can go about collecting data and things like that. Okay. Data collection and sampling. So first of all, we need to know what data collection is about. By the way, if you have not subscribed to this channel, be sure to do that so that, of course, you also hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment, like, and share. So data collection is the first thing we are looking at here, and it is that data collection refers to gathering relevant data. Relevance is key. You don't want to gather data that will not be useful for you at the end of the day. So data collection refers to gathering relevant data to address a specific research question. So it means you need to have your research question already so you can know the kind of data you need. So relevant data to address a specific research question or hypothesis. So proper sampling ensures that the data collected is representative and unbiased. Is representative and unbiased. So if you are collecting data, be sure that the sampling you have done, the data sample you have collected actually represent the whole population. If not, it will be a futile effort. Then another issue is you can actually collect data that is biased, right? So, there's a lot of manipulation going on, even in the research world, where people get the kind of data they want to validate their position, without objectivity. So, as a researcher, we don't want to go that way. So let's talk about survey design. Survey design. So survey design is the process, of crafting questions and determining how data will be collected from participants. So this is really important so you can get the actual kind of data you want. So now a well-designed survey minimizes a well-designed survey minimizes bias, ensures questions are clear, ensures questions are clear, and uses an appropriate sampling method. Appropriate sampling method to represent the target population. To represent the target population. Okay. So you can see here, right? A well-designed survey minimizes bias, okay, ensures questions are clear, and uses an appropriate sampling method to represent the target population. Okay. Now, a very good example of that would be this. A company wants to access customer satisfaction so they design a survey asking customers about their recent experiences, ensuring that the questions are simple, the questions are simple, unbiased, and direct. Okay. So that's a very good example of survey design. The next thing we want to talk about will be sampling methods. Sampling methods. Okay. So sampling methods are used to select a subset of individuals or items from a larger population. To make inferences about the population as a whole, about the population as a whole. Okay, so we have different sampling methods, right? So the first one will be random sampling. Random sampling. Okay. So here, each member of the population has an equal chance, of being selected in a random sampling, has an equal chance of being selected. Okay. An example of that would be a researcher. A researcher randomly selects 100 people, 100 people from a list of 1,000 registered voters to study voting behavior. Okay, that is random sampling. Then we can also talk about another sampling method, which is the stratified sampling. Stratified. Stratified sampling. So in the case of stratified sampling, right, the population is divided into subgroups, or what you can call strata, based on a shared characteristic and random samples are taken from each group. Okay, so an example of that would be this. A medical study divides participants into age groups, e.g., 20 to 29, 30 to 39, and randomly selects participants from each group to ensure representation across age ranges. Okay, this way you want to be sure that you have representation from different age groups. Okay, so we go to the third sampling method, which is called the cluster sampling. Random, stratified, and now cluster sampling. Okay, in this case, the population is divided. The population is divided into groups, or what you can call clusters, and entire clusters are randomly selected. This method is useful. This method is actually useful when populations are geographically dispersed. Okay, and geographically dispersed. So a nice example of this would be something like this. A national survey selects entire schools at random, and then surveys every student in the selected schools. Okay, so that is about cluster sampling. So those are three sampling methods: random, stratified, and cluster sampling. Okay, so let's move on to something else, and that is about bias and error in sampling. Bias and error in sampling. Bias and error in sampling. Okay, so bias occurs when certain members of a population are systematically more likely to be included or excluded from the sample, leading to non-representative data, non-representative data. So that is bias for you. A tendency to exclude or include certain kinds of people, certain members of the population. Okay, So we talk about selection bias. So these are different types of biases now. So you have selection bias. So selection bias, that's when the sample is not representative, is not representative due to the way, due to the way participants are chosen. For example, a phone survey, a phone survey excludes people without landlines, without landlines, resulting in bias against younger individuals who may primarily use cell phones, who may primarily use cell phones. Of course, this is probably maybe in a country where landlines are still useful. People used to still use office landlines or home landlines. But I mean, generally speaking, right? Most people actually have cell phones these days. Okay, but that's an example, a very good example to consider. So another kind of bias would be response bias. So the bias can come from the place of selection, like like the first one, but it can also come from the place of response. That's on the part of whoever is answering your questionnaire or responding to your survey. So when answer, participants answer questions inaccurately due to wording, misunderstanding, misunderstanding, or social desirability. Social desirability. That is when you have response bias. Of course, sometimes maybe you're in a hurry. I mean, it happens a lot of times. You have a questionnaire or survey to answer, and then because you are required to type very lengthy words, you will just give a very short answer and walk away. So that's why it's very important on the part of the person preparing the instrument to make it uh user friendly so that you can get something as accurate as possible. Of course, there can be misunderstanding too. There have been situations where somebody is given a questionnaire about something that is it's some technical thing that is difficult for them to understand. So the person making the instrument wants to be as clear as possible. I'm talking about social desirability, right? Some people have two answers to questions. So the one answer is what the society wants to hear, and the other answer is what they actually practice. So when surveys are carried out on very sensitive issues in society like that, you can expect that some people will just give you answers that you want to hear. Okay, so an example will be people people may underreport alcohol consumption on surveys due to due to social norms, due to social norms. Nobody wants to tell you they are alcoholics. Even an alcoholic doesn't want you to believe to think they are alcoholics. So they would rather give you if at all they agree to answer your questions. So they would rather give you something that makes them look good instead of telling you the truth. So that will lead to response bias. Okay. And then that takes us to the third kind of bias that might arise, which is sampling error. Sampling error. Okay. For sampling error now, the difference, the difference between the sample results, between the sample results and the actual population, and the actual population parameter. The actual population parameter due to random chance. So here you may not have so much power over this because of course your sampling will determine how your sampling method will determine how well you get the data that represents what you want to do, and then that will determine to what extent there's error in your sampling. So for instance, a sample of 100 people may not perfectly represent, may not perfectly represent the preferences of a population of 1,000, leading to some level of error. So I think uh, I think there's even a way to calculate the kind of sample you should take from a particular population. We may get there in the course of this. Let's see if we actually get there. Okay. Now let's go to talk about experiments and observational studies. Experiments versus observational studies. Okay. So number one, talking about experiments, right? First of all, in experiments, researchers manipulate one or more variables, which are called independent variables. And measure the effect on other variables, which we call dependent variables. Okay. Um, so they often use control and experimental groups. Control and experimental groups to draw causal conclusions. To draw causal conclusions. Okay. Example would be in a drug trial. In a drug trial, that's the process of drug discovery, making a new drug for a particular disease or something. So in a drug trial, researchers give one group a new medication and another group a placebo, because a placebo does nothing, but it can make people believe something is happening, right? So another group a placebo to test the drug's efficiency. Or I mean, in the school system, it may be something like maybe there's a new teaching technique, so that we can have two groups. One group is taught with a new technique, and another group is taught with an old technique, and then we want to see their performance at the end of the day. So that would be a very good example in the school setting. Okay. Um, so let's talk about observational studies. So you see, researchers observe variables without manipulating them. So in this case, it's not like in the case of an experiment. Researchers observe variables without manipulating them, because they're just observing without manipulating them. So these studies are useful. These studies are useful for identifying correlations. They're useful for identifying correlations, but cannot establish causality. Cannot establish causality. So observational studies are good for correlations, but if you want to see causality, experiments are necessary. You may need to hold a variable to see what happens to the other one. So you need to know your aim and go for and do what is expected to get the kind of results you are required to get. So a study observing the health outcomes of individuals who exercise regularly versus versus those who do not is a very good example of this. So you just want to see what are the health outcomes if you exercise regularly and if you do not. So in this case, since no variable is manipulated, since no variable is manipulated, like in the case of an experiment, right? Since no variable is manipulated, it's difficult to determine if exercise causes better health or if healthier people are more likely to exercise. Of course, there are literature, right, that have, actually carried out experiments in this same thing to establish that it's really important to exercise. For instance, I've once read a study that talks about making sure you walk at least 7,000 steps in a day. So I mean that's based on some experiments carried out. But of course, if it is just observational, right, you may not be able to make some bold statements. You just report what you see. So on this note, this is the end of this video on data collection and sampling. I hope it's really useful. So from the next video, we'll be doing some calculation going forward. So if you have not subscribed to this channel, be sure to do that. Hit the notification bell so you can always get alerted when a new video is released. And do not forget to comment, like, and share. You can comment, for instance, that you want me to explain something or you have a question that needs to be solved and things like that. Those are the kind of things I'll be expecting in the comments. And do not forget to like and share so that more people can see these videos, as they are really very helpful for people in different fields. Bye.